Hello and welcome to the next video on trigonometry. So in this lesson, we're going to go back and talk about coterminal angles. However, because we introduced a new unit of measuring angles called radians, the way that we go about solving for coterminal angles is slightly different, but the same exact concept. But before we get started on coterminal angles, you are going to see that we are going to be working with adding fractions quite a bit. So let's just do a quick refresher on how to add fractions. So take, for example, 2 over 5 plus 3 over 5. When we add fractions, remember, you just add the numerator and make sure that the denominator is the same. So this is equal to 5 over 5, which is actually just 1. Now let's take, for example, 1 over 2 plus 3 over 4. In order for these two fractions to be added to each other, they have to have a common denominator. So notice that these two fractions have the same denominator. However, if I were to multiply this fraction here by 2 over 2, notice this just means we're multiplying by 1. So essentially, we're not really changing anything. This ends up becoming 2 over 4 plus 3 over 4. Notice 2 over 4 is the same exact fraction as 1/2. It's the same value. However, by multiplying by 2 over 2, I ended up rewriting 1/2 as 2/4, which has the same denominator as 3/4. So when I add these together, I get 5/4, and that is my answer. Now let's take another example here. How about 5 plus 2/3? So it may seem like 5 is not a fraction, but it is. In reality, any real number is technically a fraction because every real number can technically be divided by 1. So 5 is technically the same thing as saying 5 divided by 1. Therefore, the denominator of this fraction is 1, and the denominator of the other fraction is 3. So the common denominator is going to be 3. So I'm going to multiply 3 times 3 to this fraction. So I get 15 over 3 plus 2 over 3. Again, 15 over 3 is still just 5. I just rewrote the fraction so that we have a fraction with denominator 3. So when we add these together, we get 17 over 3. And that's our final answer. Now, the last type of fraction that we may run into is when we have something like this. So here we have two fractions with different denominators. However, notice that the only common denominator here is going to be 6. So in order to make these both fractions with denominator 6, I'm going to have to multiply the first fraction by 2 over 2 and the second fraction by 3 over 3. That now allows me to rewrite these fractions as 4 over 6 plus 15 over 6. Now again, these two fractions, they're the same fractions as the original ones. However, we just rewrote the fractions to have denominator 6. But now they have a common denominator that we can add together, and this is 19 over 6. And that is the final answer. So that was just a quick refresher on adding fractions, because we will see this for the rest of the video. Now, if you remember, angles can be bigger than 360. Because after you complete one full revolution, the angle is going to continue growing. However, the cycle will just repeat itself. So every 360 degrees, the cycle just continues repeating all over again. However, in radians, again, we're not using degrees. We would be using radians. So let's take, for example, here. Let's trace out an angle. Here we get pi. This is 2 pi. That's 1 full revolution. Then here we have 3 pi, 4 pi. 4 pi is the second revolution. 5 pi, 6 pi. 6 pi is the third revolution. And so on and so forth. The angle just keeps getting bigger and bigger and bigger. Angles can also get bigger in the negative direction, if you remember that. So here we would have negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi, and so on and so forth. The angles just keep growing and growing and growing. So, when you are given an angle in radians, and you want to find a coterminal angle to the angle in radians, you are not going to add 360 degrees. This does not make sense because they are two completely different units. So for example, you're not going to get 2 feet and add 3 inches and say that this is 5 feet. That makes no sense. Same thing with radians and degrees. We are not going to mix the two units. When we're working in a unit, we have to make sure everything we do is in that same unit. Therefore, instead of adding or subtracting by 360 degrees, we're going to add or subtract by 2 pi radians. You see, it's the same concept, except we're working in the unit radians. So if you remember when we talked about coterminal angles, given any angle, if you add or subtract 360, the terminal side is going to end up in the same exact position. But again, if your angle is given in terms of radians instead, by adding or subtracting 2 pi radians, that just means the same thing as adding or subtracting 360. It just means you're going 1 full revolution right back to where you started. So when working in radians and you're asked to find a coterminal angle, you need to add or subtract by 2 pi radians. Again, you would not want to add or subtract by 360 because it is a different unit. Okay, so let's take a look at this problem. Find the coterminal angle to 3 pi radians. That is an angle between 2 pi and 4 pi radians. Now, pi over 3 radians, we know that that's 60 degrees. That's an angle that's already in the first revolution. That's an angle that lies between 0 and 360 degrees, or 0 and 2 pi radians. So we want to find the coterminal angle, the revolution after the first one. So we want to find a coterminal angle that lies somewhere in the second revolution, meaning any angle between 2 pi and 4 pi radians. So you technically have 2 methods of doing this. I'm going to go ahead and do the first method, which is the inconvenient method. This method I do not recommend you guys do. So method 1 would be to convert to degrees. So we would say here that pi over 3 radians is equal to 60 degrees. If I want to find the coterminal angle to 60 degrees in the next revolution, I'm going to add 360 degrees. And then that's going to give me a coterminal angle of 420 degrees. However, when you're given a question in radians, your answer has to be in radians. So now that yes, you did technically find the correct coterminal angle, you would not get credit because you have to give your final answer in terms of radians. So we're actually now going to have to convert this right back to radians. So to convert 420 degrees to radians, we're going to multiply by pi radians over 180 degrees, and then we get 420 pi over 180 radians, which, when you do the math and break this down all the way, you end up getting 7 pi over 3 radians. And this is the correct final answer. 7 pi over 3 radians is 420 degrees. However, because our question was given in radians, our final answer has to be in radians as well. So method 1 is to convert to degrees, find the coterminal angle, and then convert back to radians. However, this method is highly inefficient. The best method to do would be to not convert to degrees and just work in radians. So, given pi over 3 radians, we want to find the coterminal angle in the next revolution. So we're going to add 2 pi radians. This just means we're adding 360. It's the same concept. This just means we're adding one additional revolution. So now here is where the fractions come into play. Because here we have pi over 3 plus 2 pi. These do not have a common denominator. So the common denominator here would be 3. So I'm going to want to multiply 2 pi by 3 over 3. This is going to end up becoming pi over 3 plus 6 pi over 3, which ends up being 7 pi over 3 radians. And there you go. Notice we got the same exact answer regardless. But method 2 was a lot quicker because we did not have to convert. We bypassed the step of converting. Whereas method 1, you had to convert twice. Method 2, there's no need to convert. So just stick with working in radians. Now again, both methods are perfectly fine. But if you are being timed, obviously method 2 is going to be the faster method. It just requires a little bit of understanding how to add fractions. Let's do another problem then. In this problem, you are asked to find the coterminal angle to 5 pi over 6 radians, that is, in the revolution below the first revolution, meaning we're going to have to subtract one revolution. 5 pi over 6 is an angle that is in the first revolution. In fact, it is 150 degrees. We're trying to find a coterminal angle that is basically the first negative angle. So an angle that lies between 0 and negative 360, or 0 and negative 2 pi. So I'm just going to go ahead and do the quick method. I just need to subtract 2 pi. I just need to subtract one revolution. So if I got 5 pi over 6 and I subtract by 2 pi radians, there, now I have two fractions, but unfortunately they don't have the same denominator. Again, 2 pi is the same thing as saying 2 pi over 1. So I'm going to want to multiply by 6 over 6, the 2 pi. So now they have the common denominator of 6. So this is going to transform to 5 pi over 6 minus 12 pi over 6, which is going to be minus 7 pi over 6. And minus 7 pi over 6 is the coterminal angle to 5 pi over 6 that we are looking for. Notice that 12 pi over 6 is still just 2 pi. It's just rewritten so that we can actually subtract the two fractions. Okay, let's take here, for example, we want to find the coterminal angle to 13 pi over 4 radians, which is going to be an angle between 0 and 2 pi radians. So that means we need to bump this angle down one revolution. So if we were to now get 13 pi over 4, we need to subtract 2 pi radians. This is going to bump it down one revolution. Now, again, remember, 2 pi radians is the same thing as saying 2 pi over 1. It doesn't matter. It's just, this is a good ways for us to see the denominators. So our common denominator is going to be 4. So we want to multiply 2 pi by 4 over 4, which gives us 13 pi over 4 minus 8 pi over 4. Notice 8 pi over 4 is still just 2 pi. But here we now get 5 pi over 4 radians. And this here is an angle in the first revolution. Now, again, If you really want to convert to degrees so that you can add or subtract 360, that's fine. But again, you're going to have to convert right back to radians. It's a lot lengthier process. You wouldn't get points off for it because it's technically correct. You just need to remember to give your final answer in radians. However, again, it's time consuming. You don't want to waste that time. So I highly suggest getting used to solving these problems in this method. Okay, so to review what we've learned, see if you can solve these problems on your own. So here you are given an angle. You need to find the coterminal angle of the angles provided that lie in the revolution given. So for the first question, you're looking for a coterminal angle that is between 2 pi and 4 pi, which is technically classified the second revolution. In the second question, you're looking for a coterminal angle in the negative first revolution. In the third, you're looking for a coterminal angle in the first revolution. In the fourth question, you're looking for a coterminal angle in the second revolution. So see if you could figure out how to do these. Again, feel free to do any method, but I would highly suggest trying to just keep everything in radians without having to convert any units. So pause the video, give this a try, and when you come back, the answers will show up in a few seconds. And there you have it. Here are the answers. Notice that the fourth one was probably the trickiest one because you actually had to add 2 pi twice to get to the proper revolution that you needed to. So I hope that this helped. Keep practicing. You'll get the hang of this in no time. See you in the next video.